Hey, it's Miss Harris, and I'm thrilled that you're tuned in to see what's happening with Miss Harris. An equation is a mathematical sentence that shows that two expressions are equal. Why two steps? Two-step equations are called two-step equations because solving them involves two stages of inverse operations. Solving two-step equations. Step 1. Begin on the side of the equal sign that has the variable. Step 2. We will locate the constant. To remove it, use inverse operations to add or subtract on both sides of the equal sign. Step 3. Check to see what operation is used with the remaining variable and isolate it using inverse operations. If it is multiplied by a coefficient, use inverse operations to divide on both sides of the equal sign. If it is divided by a denominator, use inverse operations to multiply on both sides of the equal sign. If the variable is alone, you are done. Number 1. 3k plus 8 equals 14. We'll begin by drawing the line down the equal sign to balance the equation. Step 1. We'll begin on the side of the equal sign that has the variable. As we can see, the variable k is on the left side of the equal sign. Step 2. We'll locate the constant and add and subtract on both sides of the equal sign. We see that the constant is 8. 8 is the number that stands alone. Since 8 is being added, we will use inverse operations and subtract 8 from both sides of the equal sign. To balance the equation, we'll now be left with 3k equals 6. Now, to get k isolated, we will isolate it by either multiplying or dividing. We know that we're not done because k is not alone. K is being multiplied times 3. So to isolate k, we will divide both sides by 3. This will leave us with k equals 2. Therefore, our answer is k equals 2. Number 2, e over 4 minus 3 equals negative 19. Let's draw the line down the equal sign to balance the equation. Step 1. We'll begin on the side of the equal sign that has the variable. We'll notice that our variable e is on the left side of the equal sign. Step 2, we'll locate the constant and add or subtract on both sides of the equal sign. Our constant 3 is being subtracted. Since 3 is being subtracted, we will use inverse operations to add 3 on both sides of the equal sign. To balance the equation, we'll be left with e over 4 equals negative 16. Now our variable e is on the left side of the equal sign. E is being divided by 4. So to isolate the variable, we will multiply both sides of the equal sign by 4, which is the denominator. This will leave us with e equals negative 64. Therefore, our final answer is e equals negative 64. Number 3. 5 minus c equals 21. Let's draw the line down the equal sign to balance the equation. Step 1, we'll begin on the side of the equal sign that has the variable. Our variable c is on the left side of the equal sign. Then we will locate the constant and add or subtract on both sides of the equal sign. Here, our constant is 5. 5 is the number that stands alone. We see that 5 is positive. Since 5 is positive, we must do the opposite of 5, positive 5, which is negative 5. Negative 5 means that we will subtract 5 from both sides of the equal sign. This leaves us with negative c equals 16. Step 3, we will isolate the variable by either multiplying or dividing. We see that c is not alone because of that minus sign, which became a negative. So negative c, there is actually a number there. We know that there is an invisible 1 there to make negative c become negative 1c. Therefore, c is being multiplied by negative 1. So in order to isolate c, we must divide both sides by negative 1, since the inverse of multiplication is division. This will leave us with c equals negative 16. Therefore, our final answer is c equals negative 16. Number 4. Negative 19 equals 9 minus 7w. Let's draw the line down the equal sign to balance the equation. Now on to step 1. We'll begin on the side of the equal sign that has the variable. We see that our variable w is on the right side of the equal sign. Step 2, we'll locate the constant and add or subtract on both sides of the equal sign. Here our constant is 9. 9 is the number that stands alone. Since 9 is positive, we will do the opposite of positive 9, which is negative 9. That negative 9 will allow us to subtract 9 from both sides of the equal sign. This leaves us with negative 7w equals negative 28. We see that negative 7w, well, first it was minus 7w, but the minus sign made the 7 become negative. Now we will move on to step 3. We will isolate the variable by either multiplying or dividing. Here, negative 7 is being multiplied times w. So to isolate it, we will use inverse operations and divide both sides of the equal sign by negative 7. This leaves us with w equals positive 4. Our final answer is w equals 4. Now it's your turn. Let's solve the equation. 4r minus 16 equals 56. Are you ready? Let's go. All right, let's check our work. For this equation, your answer should have been R equals 18. Take a moment and check your work. Now on to the next problem. Let's solve the equation. 32 equals 8 plus 6K. You think you can get it? Let's go. All right, let's check our work. For this equation, your solution should have been 4. K equals 4. Did you get it? Awesome! Take a moment and check your work. All right, next problem. Let's solve the equation. Our equation is 26 minus E equals 9. Think you can solve it? All right, let's go. All right, let's check our work. For this equation, the solution should have been 17. E equals 17. Did you get it? Spectacular! Now check your work. Number 4, solve the equation. Negative J over 2 plus 10 equals 20. Think you can solve it? I know you can. Let's go. All right, let's check our work. Your solution for this equation should have been J equals negative 20. How did you do? Did you get it correct? Fantastic! Now check your work. Well, there we have it. Two-step equations is what's happening. How do you feel? Are you ready to begin the next skill? I'm honored that you participated and persevered. Tune in again and again to see what's happening with Miss Harris. Please know that you're loved and that with God, all things are possible. Toodles, toodles. Mwah.